Hello students, let's start with a new video of biomolecules. Today we'll study about pyranose structure. Now, you must be wondering what it is. Pyrene is an heterocyclic compound. The compound with 5 carbon along with oxygen atom. Okay, it also follows law of aromaticity, Eric-Huckel's rule, 4n plus 2 pi, exactly like benzene or its derivatives. Only the difference is that along with carbon and hydrogen, if you have other heteroatoms like O, N, S, then they are said to be heterocyclic. Some of the example of heterocyclic compounds are thiophene, furan, pyridine, pyragol. Okay. Now let's see the structures. These structures were proposed by Haworth, so also called as Haworth structure. Now, till date, CBSE has never asked to draw the structure, but students should be knowing the open structure of glucose as well as alpha and beta. Along with this, they must be knowing the pyranose structure. Now, if you see in the pyranose structure, you can see that you have to draw the skeleton of the heterocyclic compound. And how to arrange these groups, just go through the alpha glucose. What all the projection is on right hand side, whether it is of hydroxyl or hydrogen, is arranged in this structure. Okay students, so once again let us revise. Whatever is on the right hand side is arranged at the bottom of the structure. Similarly, you can draw the beta. Only the position at carbon number 1 will change, and it is because of anomeric carbon. So this is the easiest way to learn the structure of pyranose. If you are aware of alpha isomer, you can draw it. Right hand side all will be at the bottom, and just flip the carbon 1 and you will get beta. Now let us see the difference between alpha and beta glucose. I had already written and we have even studied in the previous video. Now let's move to the new monosaccharides, that is fructose. It is having molecular formulas exactly like glucose. It also belongs to the D series. Did you remember D-glyceraldehyde? If you see in the open structure, carbon 5 and 6. Carbon 5 is having OH on the right hand side, so it is said to be the D series member. Although the difference is that it is levorotatory, anti-clockwise rotation of plane of polarized light is observed, as well as it has ketone group. Okay. Now ketone can never be at the terminal, so that's why it is at the carbon 2, and you remember we always give lowest locant to the functional group. That's why it is carbon number 2. So in short, it is the sweetening agent obtained from vegetable and fruits, and this is your open structure of glucose. Now let's see the cyclic structure. If you see in the cyclic structure, again carbon 5 OH migrates to carbon 2 ketone group to give you alpha as well as to give you beta. Is it okay? So this is your alpha and beta isomer of fructose. Now, when we talk about cyclic structure, this is furan with carbon number 4 and oxygen atom. So that's the difference. Pyranose is a carbon with a 5 and furan is a carbon with 4 atoms of carbon. Now, easy to draw the structure. Again, if you know alpha anomer of fructose, you can draw easily the Haworth structure. This is your Haworth structure, and once again if you see the alpha, all right hand side hydroxyl or hydrogen are arranged at bottom. This is carbon 1, this is carbon 2 with OH, this is carbon 3, 4, 5, and this is the last carbon 6. Similarly, you can draw the beta isomer also. Again, just flipping of the hydroxyl group at the position of carbon 1 due to anomor. Okay. So I hope you all have understood how to draw the Hayward structure, draw the skeleton of the structure and arrange right hand side group at the bottom to get alpha, flip it to get beta. That's all for the glucose structure. In the next video, we will deal with disaccharides like maltose, lactose, etc. I hope you all will revise the monosaccharide so that it becomes convenient for you to understand disaccharides. Thank you.